नहीं.
Just 1 minute. So my voice is audible?
Yes, sir.
Okay. So now in the last lecture, we have studied this numericals on the beams. Okay. So today is your ISC examination. So in that you are having first 6 MCQ questions. Then from first topic, 2 theoretical questions, whatever the theorems and all those things which we have studied and theory. Then 1 numerical on beams and 1 numerical on the Lam's theorem. Okay, so in that way you have to prepare all the things. Yeah. So now next numerical for the beam is beam AB beam AB of
Okay.
of
चलो.
length 1.7 meter of length 1.7 meter is loaded and supported is loaded and supported is loaded and supported as shown in figure. As shown in figure. So I will draw the diagram now. Just 1 minute, wait. स्क्रीन कुठे आहे इथं खाली आहे. Zoom. वरती 11च्या ओके नव्हतं. So the diagram is this is a rectangular beam. It is supported by the supports which are shown like this. This is your point A, the support provided at point A, and also the support is provided at point B. This support is the roller support which is provided at point B. This is at point B. Now loading is also given to us. First, here is a load of 50 kilonewton. Load is 50 kilonewton. Second, 20 kilonewton, which is inclined at an angle of 60 degree. This load, this is angle is 60 degree, and this is 20 kilonewton. Next load is 30 kilonewton. This is the load of 30 kilonewton. And this angle of inclination is 45 degree. And this load is 30 kilonewton. Now the distances are also given to us. So the distances are from this A point up to this 50 kilonewton meter. It is 20 centimeter. Okay, so this distance it is given as 20 centimeter. Then from this point up to this incline force, it is given as 40 centimeter. This is given as 40 centimeter. And then the distance between these two loads is 70 centimeter. So this distance it is given as 70 centimeter. And at last, this is now again 40 centimeter. Is 40 centimeter. So total length is 1.7 meter. Total length is 1.7 meter. So if you see here, 70 plus 40 plus 40. Okay, 70 plus 40, 110, 110 plus 40, 150 plus 20, 170. So it is 1.7 meters. If you take in meters, now this is given in the centimeter. So you can say 0.2 meter, 0.4 meter, 0.7 meter, again 0.4 meter. This is the division of the total length it is given. Okay. Now the numerical is we need to find out the reactions. Okay, so here I will write determine reactions. Okay, so we need to determine the reactions. Now how we are going to solve this? Now see here, just a moment. Okay, so here you can see this is the vertical load, this is inclined load. So if you resolve this, you will get two components, one in y direction, another is in x direction. This is here also you will get the two components. Now first of all, at point B you can see roller support is there. So how many reactions are there for the roller support? So roller support always having only one reaction. Okay, but that reaction is always perpendicular to the surface on which the roller rests. So this reaction is all perpendicular to this horizontal surface. So the reaction will be vertical. The reaction will be vertical. Another support is this support. This support must be the hinge support, which is having two reactions. One is vertical, another is horizontal. Okay. So if we draw the reactions now, so here I will get only one reaction, RB. Okay, I will draw here RB, only one reactions, and here I will get two reactions. Okay, at point A we will get two reactions. Here I can call this as RB. This angle is 90° with the surface. So the reaction is vertical at point B. Here I will call the horizontal reaction as HA and vertical reaction as VA. Horizontal reaction as HA and vertical reaction as VA. Now we will solve this problem. Okay. And there is one more force is given of 80 kilonewton at an angle of 80 degrees. Sorry, I forgot to show this force. Here at point B, there is one more force at this point B. Okay. And this force is of 80 kilonewton. Okay. This force is of 80 kilonewton and its angle with horizontal, this angle, they have given it as a 80 degree. This is at point B. So this is now the given diagram. Okay, this is now the given diagram.
Sir, VH's जागी RA पाहिजे ना.
No. Why here it is RA? RA is the resultant reaction of VA and HA. There are two reactions at this point. Okay. See here. Here are two reactions are there. One is horizontal reaction HA. Another is vertical reaction VA at this hinge support. When the simple support is there, whenever there is only one reaction is there, then you can say that RA or RB or whatever it may be. But when a support is having more than one reaction, now here you can see at hinge support two reactions are there, so more than one. So we will call this as vertical component as VA and horizontal component of reaction as HA. And when you find out the resultant of these two, then that will be your RA. That will be your RA. Okay, if you find out, suppose now if I complete here parallelogram like this, okay, and if I join the diagonal of the parallelogram, then this is nothing but this is my RA. This is RA. Why I am getting RA here in this way? Because this support is having two reactions. Whatever resultant of two reactions is there, that is my RA. Here in the case of RB, you can see there is only one vertical reaction. There is no horizontal reaction. So you can call this reaction directly as RB. But whenever hinge support is there or fixed support is there, you will get two reactions over here. One is vertical, another is horizontal. So the reaction of these two is nothing but RA. Sorry, resultant of these two reactions. Okay, resultant of HA and VA is known as RA. समझ लगा?
Sir.
Okay. So now we will move further and we will solve this numerical. So this is our VA. Okay. Now what I will do, this is our point A. This is our point B. Okay. Now this type of diagram is given. So in this diagram, are you able to understood or should I draw a simple line diagram? Instead of this thickness, you can also draw a single line. If you want, you can also draw a single line, and on that single line, you can show all the forces and reactions also. Okay, it is one and the same thing. So now if I apply, see here, now I want to calculate these three values. What is the value of RB? What is the value of HA? What is the value of VA? These I need to calculate. So first of all, what I will do, I will take the moment of all the forces about A equal to 0. At point A, I will take the moment of all the forces 0. So what will happen? HA is passing through point A, so its moment will be 0. VA is also passing through point A. So its moment will be also 0. What will remain? RB. So we will get the value of RB if we apply this equation. So before moving further, what I will do, I will resolve these inclined forces. So if I draw a simple line diagram for your understanding over here, see, I will draw one simple diagram. This is our beam which is given to us. Here are the different forces are acting. So those forces are, this is 50 Newton, 20 Newton, 30 Newton, sorry, and here at this point 80 Newton. These are the forces which are acting. Now if we show the reactions, here your reaction is RB, here your reaction is VA, and the another reaction is HA at point A. So at this point, this is A, this is horizontal reaction at point A, vertical reaction at point A, this is RB, this is the load of 50 Newton, here is the load of 20 Newton, this is the load of 30 Newton, and this is 80 Newton. Now the angle of this force, it is 60 degree, angle of this force, it is 45 degree, and here the angle is 80 degree, and the distances are given. Okay. So the distances here 20, 40, 70, 50. Okay, so I will write it in meters. This is 0.2 meter, then this is 0.4 meter, this is 0.7 meter, and again this remaining is 0.4 meter. So these are the distances given to us. Now what we are going to do, we are going to take the moment of all the forces about A equal to 0. Clockwise moment is positive, anti-clockwise moment is negative. So before taking the moment, we will resolve the force. We will resolve the force. So now if I resolve the force here, this 20 Newton, then what do I will get? I will get, this is my point of application. See, this is the point of application. Okay, this is the force, it is acting on the beam. Now this is my point of application. We always draw one line parallel to X and another line parallel to Y from the point of application. Remember this, we will always do it from the point of application. Now this is my point of application. So I will draw one line parallel to X, which will be in this way, parallel to X. Another line parallel to Y. This is the line parallel to Y. And I should draw these two lines in such a way that your main resultant force should come in between these two. This we have already studied. So this will become 20 sine or cos?
Sine.
This is 20 sine 60. And this is 20 cos 60. Now similarly, if I resolve this force now, so this is the vertical component and the horizontal component will be like this. Here it is the horizontal component. So if I write here, this angle is 45 degree, then this is 30 cos 45 and this is 30 sine 45. Now again, if I resolve the remaining force, this force, if I resolve this force, then again what do I get? So here parallel to Y, parallel to X, two components, this is 80 cos 80 and here it will be 80 sine 80. Okay, 80 sine 80. So these are the components. Now these forces we should consider in our calculation. So when I apply moment about A equal to 0, then here what I am going to do now, I will write the equation first. So I am taking the moment of all the forces at this point A. So HAVA will become 0 first thing. HAVA will become 0. Then this 20 cos 60, if you see this force 20 cos 60, it is acting over here. If you extend its line of action, then it will also pass through point A. So its movement is also 0. Okay, because perpendicular distance becomes 0. Then this 30 cos 45. Again, now this 30 cos 45, it is moving towards the right side. But if you, what we can say, see its line of action, and if you taken it backwards, see its line of action is also passing through point A. So the moment of 30 cos 45 is also 0. Now this 80 cos 80. If you see this 80 cos 80, this 80 cos 80 is also passing through point A. Okay, line of action of 80 cos 80 is also passing through point A. So its movement is also 0. Now we will see the remaining forces. First is this 50 Newton. So it is 50 into, what is the distance? Now here is the force of 50 Newton.
0.2 meter.
0.2, correct. So the distance is 0.2. Clockwise or anti-clockwise? Plus minus kasa yenar?
Clockwise.
Clockwise. So this is plus. This is plus. Now when I come to the next force, this is 20 Newton, but don't consider this main force now. Now consider its component for the calculation once you resolve the force. So I have told you this thing many times. These things, that is, don't consider the main force, consider its components for the calculation. Now here 20 cos 60 is, it is already 0. 20 sin 60. Now 20 sin 60, what is the distance from point A?
0.6.
0.6, correct. So it is 20 sin 60 into 0.6 into 0.6. This is also plus. Now next is 30 sin 45. 30 sin 45 into. So here you can see this is 30 sin 45. So this 30 cos 45 is already 0. 30 sin 45. What is the distance? 0.7 plus 0.4 plus 0.2.
1.3.
1.3. Okay. So it is 1.3. It is again moving down. So you can rotate this about point A. It will rotate in clockwise direction. Plus. Now next is this 80 cos 80 will become 0. 80 sin 80. So plus 80 sin 80 into, what is the distance?
1.7.
1.7. Okay. And lastly, this RB. The distance of RB is again 1.7, but RB is moving upward. So if you take this RB up and then if you rotate about point A, it is which direction?
Minus 1.7.
Minus, correct. It is minus 1.7 RB is equal to 0. So therefore, now if you solve this, you will get the value of RB. Let me know the answer.
रूम बघितला म्हणलं तर इथंच बघितली म्हणताय
Roll number 44.
यायचं नाही बरं
Yes,
बरं आहे की
Kulkarni.
चेष्टा करू नको खायला हव्या
What is the answer?
$126.74.
126.74 Newton. I don't know the correct answer. Is this answer is correct?
Yes, sir.
Okay. So have you got positive answer or negative answer?
Positive.
positive. So our assumed direction of RB is correct. RB is moving upward. Our direction, whatever we have assumed, is correct. Okay. So now once you calculate the RB, now it is very easy to calculate VA and HA. So now apply summation Fy equal to 0. Okay. So apply summation Fy equal to 0. Upward forces plus downward forces minus. So now here you can see upward forces. So VA is moving up plus VA. 50 Newton is moving down minus 50. Then this 20 sine 60, this is also minus. Then this 30 sine 45, this is also minus. And then this 80 sine 80, that is also minus. Okay. So here now VA minus 50 minus 20 sine 60 minus 30 sine 45 minus 80 sine 80 sine 80 plus RB equal to 0. This is our equation of summation Fy. What is the value of RB? It is 126.74. It is 126.74. Okay. So put that value over here. The value of RB. So here you can put this RB is 126.74. If you put this value, you will get the value of VA. Roll number 44, are you there? Are you able to hear me? Roll number 44. Who is 44? Kulkarni, I think so.
सेकंड फ्लोअरला मेकॅनिकल मी बघून आलो मेकॅनिक CS आणि NTC लय भारी कॉलेजेस
Roll number 44. You are not attending the lecture.
मेकॅनिकल
What are you doing here? If I remove
अरे
you
पहिला
from this meeting,
उजव्या बाजूला इकडे जाईल
just 1 minute. That roll number 44 is disturbing the whole class. Okay. What is the answer? Anybody have calculated that? 40.57. Okay. So the answer किती आलं? हे बरोबर आहे का? 40.57.
Yes, sir.
Okay. So now after this we will apply summation fx equal to 0. So apply summation fx equal to 0. Towards right plus, towards left minus. Okay. Towards right plus, towards left minus. Then here it is from HA we will start. HA is moving towards right hand side. So HA is positive. Then the horizontal force is this 20 cos 60. It is moving towards left hand side. So this is negative. 30 cos 45. It is moving towards right hand side. So this is positive. And next is 80 cos 80. It is moving towards left hand side. So it is negative. So we will write all these forces. So HA plus minus 20 cos 60 plus 30 cos 45 minus 80 cos 80 is equal to 0. Therefore, HA is equal to
2.67.
2.67. So here we have got positive answer, no? So value of VA is correct. And here also we have got positive answer. So what is the direction we have assumed for HA? Towards right. So our direction is correct as we have got the positive answer. So HA is moving in this direction. Okay. So now after the calculation of HA and VA, you can see over here, HA and VA are the reactions at point A due to hinge support. So now we will calculate the resultant of these two. Okay, so the resultant of HA and VA will be like this. If you complete the parallelogram, then I have shown it earlier also. So this is your reaction RA. Okay, resultant RA. And this angle will be alpha A. This angle will be alpha A. So we will calculate the RA now. So the resultant reaction at point A, which is RA is equal to, how do we calculate? Same, by using same formula, under root HA square plus VA square. So R is equal to under root summation fx square plus summation fy square वापरता ना. Same way RA is equal to under root HA square plus VA square. So if you put the values, you will get the answers. So VA is 40.57 square plus 2.67 square HA and VA. So therefore, RA is equal to, calculate the value.
$40.65.
40.65 Newton. This is the value of RA. Now we want to find out alpha A. So how do we find out alpha A? If you look at this figure here, this angle is alpha A. Okay, this is RA, this is VA, and this is HA. So this is VA means this vertical also VA, and this is HA means this is also HA. Now if you consider this triangle here, this angle is 90 degree, this vertical is VA, this horizontal is HA. If I use tan of alpha A over here, I will roughly write here, see. Here if I write tan of alpha A. So from this triangle, what you will able to tell me from this triangle? It is opposite side divided by adjacent side. So opposite side is VA and adjacent side is HA. So this is the formula for tan alpha A. Okay, so there is no need to by heart this formula. From this diagram, you can easily calculate this. So I will use this formula over here. So tan of alpha A is equal to, or instead of, I will directly write alpha A is equal to, why to increase one step. So alpha A is equal to tan inverse in mod VA upon HA. So which is equal to tan inverse of VA is, VA is 40.57 and HA is 2.67. So if you solve this, you will get the answer alpha A.
86.23.
86.23. Okay. I will write 86.23 Newton. Sorry, not Newton, it is angle, so it is degree. 86.23 degree. So this is the alpha A. Now this is the numerical which we have solved. Hope you have understood this numerical. समजले का काय केलं ते? Yes or no?
Yes, sir.
Okay. So now
Yes, sir.
we will take the text numerical.
सर
बोला.
सर एक शंका होती.
हा.
सर आपण समेशन एम घेतो तेव्हा सगळे जे फोर्सेस ते अकॉर्डिंग टू एक्स ऍक्सिस कडून घेतले आपण अशी कंडिशन नाही येणार का कधी आपण वाय ला अकॉर्डिंग करून
Y ला अकॉर्डिंग करून म्हणजे काय? समेशन एम मध्ये सगळेच फोर्सेस घेतोय की आपण. हे जर पॉइंट आहे ना, हा ए पॉइंट, हा ए पॉइंट जर असा खाली असला असता आणि तुमचा हा जो फोर्स आहे 30cos45, हा फोर्स जर असा इथं या डायरेक्शनला असला असता 30cos45, तर ह्याची मुवमेंट झिरो झाली नसती. त्या केसमध्ये हे तुम्हाला व्हर्टिकल डिस्टन्स एक्स काय असेल ते घ्यावं लागलं असतं. पण आता थिंक काय, आता सध्याला गोष्ट इथं काय या प्रॉब्लेम मध्ये, तर हा 30cos45 जो फोर्स आहे तो इथंच ऍक्ट होतोय या पॉइंट वरती. समजलं का? हा जर पॉइंट इथे आहे ए आणि फोर्स इथे आहे तरच व्हर्टिकल डिस्टन्स येणार ना कॅल्क्युलेट करताना, अदरवाइज येणारच नाही.
ओके सर.
समजलं का काय सांगितलं ते?
हा समजलं सर.
ओके. आहेत अजून भरपूर प्रॉब्लेम आहेत, पुढे पुढे येतात सगळे प्रॉब्लेम. त्यावेळेला तुम्हाला लक्षात येईल. सो now we will take next numerical. A beam AB 6 meter long, loaded and supported as shown in figure. Calculate the reactions. So now we will draw the diagram. So this is AB. So at this point A, hinge support is there. This is the support which is giving at this point A. At point B, again ruler support is given. Horizontal surface. Then some loads are given. So here the load is 5 kilonewton. But here it is 4.5 kilonewton, which is inclined, and in between them UDL is there. So this is 5 kilonewton. This is 4 kilonewton. This angle it is given as 135 degree. And here is the UDL of 1.5 kilonewton per meter. 1.5 kilonewton per meter. And the distances are 2 meter, and this is also 2 meter. These are the given distances. This is the point A, this is B. And we need to find out the reactions. First of all, we will draw the reactions. How many reactions will be there? So the reactions are here. Now this is the roller support at point B. How many reactions are there for the roller support?
One.
One reaction, and that reaction will be perpendicular to the surface. Okay, so I will draw this reaction over here at point B. So this is the reaction RB. Only one reaction is there, so I have directly written over here RB. There is no need to find out the resultant of the reaction because there is only one reaction. So now here at point A, see in the numerical, here is inclined load is given. So inclined load is there, therefore it has two components, horizontal and vertical. So horizontal load will be there, which is acting on the beam. And to resist that horizontal load, you must have horizontal reaction. So here at the point A, hinge support is given. So for hinge support, two reactions are there. One is vertical and another reaction is horizontal. So these are the two reactions. This is the HA horizontal reaction, VA vertical reaction. Now we need to calculate the reactions. Okay. So how to solve it now? You tell me. How to solve this?
Momentum is equal to 0.
Moment. Where you are going to take the moment, at point B or at point A?
At point A.
Point
why,
A.
why not at point B? Why you are not going to take the moment at point B? See, instead of at point A, if I take the moment at point B, what will happen? See, if you take the moment at point A, you will get the answer reaction RB. Okay, you can get the value of RB. And if you take the moment at B, then your RB will become 0. Your HA will become 0 as HA is also passing through this point A. You will get the value of VA. Okay, so either way you can solve it. If you want, you can take the moment at point A. If you want, you can also take the moment at point B. कुठल्या पॉइंटला घ्यायचं बघ सांगा. तुम्ही ज्या पॉइंटला सांगाल तिथं घेऊ आपण आज मुवमेंट. ए ला घ्यायची का बी ला?
ए लाच घ्या सर.
ए लाच घ्यायचं, ठीक आहे. हा, बिफोर दॅट वी नीड टू रिझॉल्व द फोर्स ऑफ दिस 4 kilonewton. Now you tell me how to resolve this force. So I will draw the components. No, how to resolve this? सांगा लवकर लवकर बोला. 4 kilonewton फोर्स आहे, 135 डिग्री अँगल दिलेला, ह्याला रिझॉल्व करायचंय. कसं करायचं?
एक एक्स ऍक्सिसला आणि एक वाय ऍक्सिसला रिझॉल्व करा.
एक ऍक्सिसला आणि वाय ऍक्सिसला रिझॉल्व करायचं. म्हणजे एक काय येणार 4 cos 135 आणि दुसरा काय येणार 4 sin 135. बरोबर ना?
सर.
No, sir. The angle should be below 60 degree.
Below 60 degree?
Less than 60 degree.
Less than 60 degree?
Less than
180 minus 135 degree.
नाही, हे अँगल येईल, पण नॉर्मल आपला क्लॉज काय सांगतोय, व्हेन यू वॉन्ट टू रिझॉल्व द फोर्स, दिस अँगल मस्ट बी अ acute angle. This angle must be acute angle, then and then you can use it for the resolution. Now if you see, this angle is not acute angle. This angle is not less than 90 degree. अँगल हा कधीच पण 90 डिग्री पेक्षा कमी असायला पाहिजे, तरच तुम्ही त्याचं रिझोल्यूशन करू शकता तो फोर्स. इफ युअर अँगल इज मोर दॅन 90 डिग्री, देन यू कॅन नॉट रिझॉल्व दॅट फोर्स बाय दॅट अँगल. ओके, मग इथं जर बघितलं तर हा अँगल तुम्हाला 135 दिलाय, but you cannot resolve the force by using this angle 135. Okay. So now here what I will do, instead of taking this angle, I will go by this side. Okay. Just a minute. So I will go by this side, this side. So now this total is 180. This total is 180. 180 minus 135. What is the angle?
45.
45. Okay. So this angle is 45 degree. Now this angle 45 degree is less than 90 degree. So that we can resolve the force now. So now if I resolve it, here I will get two components. One is vertical, another component is horizontal. And now I can write over here, this is 45 sin 45, this is 45 cos 45.
So 4.
4 sir, 4 sin
4 है
45.
क्या?
हाँ sir.
Right, sorry. So 4 sin 45 and 4 cos 45. Second load is UDL, so no need to resolve. And then the point load of 5 kN. Okay, so now quickly we will take the moment at point A. So I will write the equation, see the equation carefully, and if you are having any doubt, you can ask me. So clockwise positive, anti-clockwise negative when we are taking the moments. Now here we are taking the moment at point A. So first force is 5 kN. So it is 5 into 2, rotating in clockwise direction, so positive. Next is this UDL. This UDL is of 1.5 kN per meter, that is a rectangular load, and its length is 2 meter. Okay, so first of all, we need to convert this UDL into the point load. So how to convert that? It is 1.5 into 2. It is 1.5 into 2. This is not a moment still. This is only the conversion of UDL into the point load. Now what will happen? When you do this 1.5 into 2, you will get a point load. And that point load will act at the center of this span. Center of this 2 meter. So center of this 2 meter means from 5 kilonewton it is at a distance of 1 meter, and from this 4 kilonewton it is also at a distance of 1 meter. So it will act at the center here. So if I take the moment from point A, now we are taking the moment from point A. See here I will show you that force. This force will act somewhere here. Okay, and this is your force of 1.5 into 2. Then what is the distance? What is the distance? Distance will be 2 plus 1, 3. So distance is 3. Again, this is moving downward, so it will rotate in clockwise direction. It will rotate in clockwise direction. So here now, next is, this is the moment of UDL. Next is this 4 kilonewton. Now we have resolved this 4 kilonewton into two components. This 4 cos 45, if you extend its line of action behind, then it will passing through point A. So this 4 cos 45 will become 0. 4 sin 45, what is the distance of this 4 sin 45? What is the distance? 4 sin 45 into 4. Okay. 4. So into 4 plus. Then last one is this RB. RB distance is 6 from point A. So here, and it is moving up, so we'll rotate in an anti-clockwise direction. Minus 6 RB is equal to 0. Therefore, RB is equal to
20.88.
20.88. Positive answer आला है ना?
Yes, sir.
So our assumed direction of RB is correct. It is moving upward. Okay, now apply summation Fy equal to 0. Upward plus, downward minus. So here you can see this VA, it is moving upward, so plus VA. 5 is moving downward, minus 5. Then this 1.5 into 2, that is the conversion of UDL into the point load. So 1.5 into 2, this force will move downward. Okay. Then this 4 sine 45, this is also moving downward, again minus, and RB is moving upward, this is plus. So I will write over here the equation. It is VA minus 5 minus 1.5 into 2 minus 4 sine 45 plus RB is equal to 0. Now put the value of RB so that you will get the answer. What is the value? 20.88. Put this value over here and let me know what is the value of VA.
minus 10.05.
Okay, so value of VA is minus. Now we have got the minus value 10.05.
05.
Okay, all of you also check the answers. VA is minus 10.85 kilonewton. Now here you can see in the problem, we have assumed that VA is moving upward. Okay, आपण काय assume केलं होतं, VA upward आहे म्हणून. पण VA चे आन्सर कसा आलाय, निगेटिव्ह आलाय. याचा अर्थ काय असणार आहे, VA अपवर्ड असेल का डाउनवर्ड असेल?
Down.
We have to change the direction of VA because we have got the negative answer. So therefore I will write here VA is 10.05 kilonewton. This minus sign is for the direction, it is not upward, it is moving downward. So in the main diagram also, now here where I have shown, here I will erase this and I will show the correct direction of VA. I will show the correct direction. So this will be the correct direction of VA. This is the VA. Now apply summation Fx equal to 0. Now if you apply summation Fx equal to 0, forces towards right are positive, forces towards left are negative. Then here you can see this HA, we have assumed that it is moving in the right hand side, so HA will be positive. Then next force will be this 4 cos 45. It is also moving in right side, rightward direction. So this is also positive. There is no any other horizontal force. There is no any other horizontal force. So it will be HA plus 4 cos 45. So if you apply summation Fx equal to 0, then it will be HA plus 4 cos 45 is equal to 0. So HA is equal to, what is the answer?
Minus 2.82.
Minus 2.82 kilonewton. So therefore we need to change the sign of the direction of HA also. Here you see that HA we have assumed to the right hand side, but we have got the negative answer. So the value of HA will be 2.82 kilonewton, but the direction is reverse. In this direction it is going. So here also in the main diagram, I will change the direction of HA. Correct direction I will show. Because now we know the correct direction. So this is the correct direction of HA. Okay, correct direction of HA. Now after VA, you can find out the resultant of these two, which is RA. Resultant of these two, which is RA. See, and that RA will be in this direction. This is your RA direction. And this angle will be alpha. Okay. So now if I calculate RA is equal to under root HA square plus VA square plus now what is the value of RA?
10.43.
10.43 kilonewton. So this is RA. And therefore alpha A we need to calculate. Therefore alpha A is equal to tan inverse in mod, it is 10.05 divided by 2.82. So alpha is equal to, calculate the value of alpha.
Twenty-nine point 89.
29.89 degree. So this is the answer. Okay. Now for today, we will stop over here. In the next lecture, we will see more numericals. Is there any doubt, difficulty in this numerical? Anybody is having any doubt? Okay. So now I will take the attendance. Today date is 8th February. Roll number 1,
Present.
2,
Present, sir.
3, 4.
Present, sir.
Okay, in today's lecture, I have observed that 3-4 students have joined lately to the lecture. That is, I have enabled a waiting room after start of the lecture. This is the first time I have observed. I am telling you, please join the lecture on time. If you join the lecture after half an hour or after 40-45 minutes, what is the use of this attendance? Okay, this attendance, the lecture is most important than your attendance. Make it clarify these things to yourself, because once you miss the lecture, you will not get anything from the further topics. All topics are interrelated, interdependent. So this is the first time, that is why I am taking the attendance also, and I am giving you, you can take it as a warning from my side, that you should always join the lecture 5 minutes before your teacher. Okay. So please remember, those students who have came late, please remember this. So roll number 4.
Present, sir.
5.
Present, sir.
6. Roll number 6. 7. 8.
Present, sir.
9. 10. 11.
Present, sir.
Present, sir.
12.
Present, sir.
13.
Present, sir.
14.
Present, sir.
15.
Present, sir.
16.
Present.
17.
Present, sir.
18.
Present, sir.
19.
Present.
20.
Present, sir.
21. 22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present.
29, 30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
34, 33,
Present, sir.
34,
Present, sir.
35, 36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39, 40,
Present.
41,
Present.
42, roll number 42, 43,
Present, sir.
42 is also present. Okay.
Present,
sir. 44.
Present, sir.
Who is roll number 44? Roll number 44. Are you able to listen me? Ha, Yash Kulkarni, Mr. Yash Kulkarni, from where you are attending the lecture?
Kulkarni.
हा? तुम्ही लेक्चर अटेंड बाहेर फिरून लेक्चर अटेंड करताय का गाडीवरती मित्रांसोबत? हा, you have disturbed the whole class today.
बाहेर आलो सर, बाहेर आहे.
अहो मग बाहेर आला तर तुम्हाला म्यूट करता येत नाही का? जर कॉलेज असला तर तुम्ही बाहेर फिरू शकला असता का? हा, लेक्चर आहे आणि तुम्ही अजून मला सांगताय मी बाहेरून लेक्चर अटेंड करतोय. देर इज नो सिरियसनेस इन सी.
अहो सर, कॉलेजवर चालतो सर.
But then why you are not here in the classroom? I am there in the classroom in the college.
हॉस्टेल
Why?
बघायला आलतो सर.
You have disturbed me whole throughout the lecture. At last, I have put you in the waiting room because of your disturbance. You come to my cabin and
Sorry
meet
sir,
me.
sorry sir.
You come to my cabin. Now you are in college. Okay. So 45.
Present, sir.
46. 46 is present. 47. 48. 49.
Present, sir.
50.
Present, sir.
51. 52. Present. Okay. 53.
Present, sir.
54.
Present, sir.
55.
Present, sir.
56. 57.
Present, sir.
58. 59.
Present, sir.
60. 60 is present. 61.
Present, sir.
Okay. Now I will call the absent roll numbers which I have taken. Now somebody from these roll numbers is present. Then you can give me your attendance. Okay.
Sir,
Roll number,
hello, sir. 35 present.
okay. Roll number 6. Then roll number 9.
Sir.
Roll number 6.
present.
Roll number 9. Roll number 39. Then 47. 56 and 48. These are the roll numbers which are absent for today's lecture.
Sir, roll number 7 present.
I have not taken your roll number in the absent count. After 6, I have called the roll number 9. So it means that 7 is present.
58 present, sir.
58 present. I have also not taken your roll number. Okay. Next. 6, 9, 39, 47, 48, 56. Out of these roll numbers, if anybody is present, you can tell me right now. Okay, so now for today we will stop over here. The remaining portion we will cover in the next lecture.